Hey folks, welcome to Open Source Options. Today I'm going to show you how to generate random numbers in Python using NumPy or NumPy, however you prefer to pronounce that. There's been a recent update to NumPy, and so if you're using version 1.22, this is now the correct way. The correct way to generate random numbers changed in NumPy 1.22. So let's go ahead and get started. We're just going to start off by importing NumPy as NP, and I'll just note that I'm using a Jupyter notebook here in Visual Studio Code. It's pretty slick, and if you want to see how to do that, you can check out my video on it. I'm going to use my base and a convert interpreter, and we'll let that run. Okay, so the first thing we're going to do is we're going to generate just a random floating point number between 0 and 1, and first we're going to get a random number generator, which is which we get this RNG variable, and so we'll do np.random.default RNG, default random number generator. Now let's go ahead and shift enter and run that. Now it's super easy to get a random number from this point. We're just going to do RNG.random. Shift enter, and there you can see I have a random floating point number. We can run it again, and you can see we have a different floating point number. Simple as that. That's how you generate a random floating point number between 0 and 1. Okay. Now, we might want to generate more than one random number. So let's say we want to generate a list or an array of 10 random numbers. So do RNG.random. We're just going to give it a size here. We'll give it 10. Now you can see I have an array with 10 random numbers between 0 and 1. We can do different shapes. We could do RNG.random, an array with 3 rows and 2 columns, and there you have it. And I'm just going to note here too that the code for this is on the website if you want to copy and paste over, and I'll include a link for that in the description. All right, now there might be times you want to seed a random number just to make sure things turn out the same every time. We can do that by seeding the default RNG. So we can do RNG seed equals np.random, np.random.default RNG, and here I'm just going to give it a 1, 2, 3, 4, 5. Okay, and now we'll do RNG seed.random. Okay, now just to demonstrate this, when we come back up and run this line of code up here again, we're going to get different random numbers if I run this. Okay, so I'm going to run it again, and you'll see that the numbers there change. So I'm getting different random numbers each time. Now I'm going to run this block of code, and you can see I got 0.227. Run it again. Every time I run it, I get the same number because I've seeded it with this value, and so this makes it reproducible when I seed values. All right, let's go and do some random integers. We've done random floating point numbers between 0 and 1, and those can be scaled. But let's go ahead and do some random integers here. And we can use, once again, our default random number generator, RNG, and we can do integers. And here we just need to give it a low number and a high number. So this will generate a random integer between 0 and 10. Hit enter, and there I got 0. We can go up and run that again, and we get 4. Now, just like with the floating point numbers, we can also give it a size. So we can do RNG.integers. We can give it, I'll put the keywords in here. So we have low equals 0, high equals 10, and size equals 10. And if I run this, I will get an array. Okay, we can do this again with a different shape if we would like to. So we can do RNG.integers, low 0, high 10, size 3 by 2. And there you have the 3 by 2 array. So that's integers. Let's go and talk about generating random numbers from statistical distributions. And the random number generator has a lot of functionality here, and we're going to go through just a couple of examples. I'm going to import matplotlib to show how this works out. So we can plot these distributions. .pyplot as plt. All right. And let's just come over here and let's just add a percent matplotlib inline. And then we'll come down here and we'll set our figure size so things are a little easier to see. So we'll do plt .rc params. And then we need to do figure fixed size. Let's do about 9.5 by 6. Okay, and let's hope this all runs well. Looks like it did. Okay, so now we can generate some figures of statistical distributions. So let's start with the standard normal distribution, and this is going to be a normal distribution with a mean of 0 and a standard deviation of 1. And so we'll just plot this. We can do plt.hist, and we can generate this. We can do with our random number generator, and we're just going to do standard normal, and we're going to generate 1,000 samples. So let's hit Shift Enter to run this. You can see it prints out the array, and there you can see the figure with our statistical distribution that resembles a normal distribution. All right. Let's go on to another one. Let's go just do a normal distribution that's not the standard normal. So we'll do plt.hist. We'll do RNG, and we can do normal here. And now we need to specify a mean and the standard deviation and the number of samples. So let's specify a mean of 10.5. Oops. Of 10.5. Let's specify a really high standard deviation, something like 6.7. Let's generate 10,000 samples. Hit Shift Enter to run that. And you can see here that we have a plot centered, just past 10 with a very wide distribution. All right, let's just do a couple more examples here. Well, maybe just one more example. All these are going to work out relatively similar to each other. You're just going to have different distributions with different scale parameters. So let's work with an exponential distribution here. So we can do plt.hist rng.exponential, and we're going to give it a scale factor of 100, and then we'll give it, we'll generate 10,000 samples, run that. You can see how that exponential distribution shakes out. So there are a number of these. There's log normal, there's Poisson, there's all these standard distributions that you can generate random numbers from. So that's how you can generate random numbers in Python the right way for NumPy 1.22. Hope you found this useful. Again, the code's on the website if you want to go copy and paste from there, and come back to another video sometime.